Compound inequalities. A compound inequality contains at least two inequalities that are separated by either and or. That's the key. That's how you know you have two of them. So here's an example of an and. Graph the solution x is greater than or equal to 2 and x is less than or equal to 5. So we would go to 2 with a closed circle to the right, and we would mark 5 with a closed circle to the left. The graph of a compound inequality with an and represents the intersection of the graphs of the inequalities. So x is greater than or equal to 2 and x is less than or equal to 5 can be rewritten using the intersection symbol. It looks like an upside down U, kind of like a little hill, but that's the symbol for intersection. A number is in the solution to the compound inequality if the number satisfies both inequalities. So this makes the solution all of the numbers that are shaded both red and blue. So the only part that's red and blue from above was from 2 to 5. So now that's the only part shaded, that in-between piece, that intersection. So here again, we have x is greater than or equal to 2 and x is less than or equal to 5. So in this example, the red and blue shaded regions overlap. A slight adjustment to the first inequality results in 2 is less than or equal to x. You're just switching the sides of the inequality, so you switch the symbol, and you kept the second one the same, which implies if we write it as 1, that 2 is less than or equal to x, which is less than or equal to 5. And x is there in between 2 and 5 inclusive. You do actually have 2 and 5 as well. This is now an example with an or compound inequality. We have x is less than -3, so we marked -3 with an open circle and shaded to the left. Or x is greater than 1, so we marked 1 with an open circle and shaded to the right. The graph of a compound inequality with an or represents the union of the graphs of the inequalities. So union we can actually rewrite with a symbol U. That's the symbol for union. Very easy to think of. It's a U. So a number is a solution to the or compound inequality if the number is in either the blue or the red shaded regions. So your blue and red just both become purple. Any number in those areas is a solution. Here's another example. Let's go back to and just to make sure we're understanding what we're doing. So we have x is greater than -8 and x is less than -3. So it's equivalent to the intersection of the two inequalities. So therefore, if we rewrite the first, if we switch the sides, we switch the sign, and then combining the two gives us -8 is less than x, which is less than -3, which means x is between -8 and 3. Now, this is not inclusive. We have open circles. We're not including -8 and 3, but we have all the values in between. Those are how you want to think of your compound inequalities, whether and or, whether union or intersection.